All right, so today I'm very happy to introduce Andres Rodriguez. He's a data analyst at Progressive Insurance, and he blogs at socceranalyticsfc.com. And today he'll be sharing with us how he modeled the transfers of European soccer players. So go ahead, Andres.
Thank you, share. This one, yeah. And then, in case you're wondering what this whole mess is, it's Guernica by Pablo Picasso. It's a nice picture, so I like it.
Very artistic background.
It really is. And like, on a side note, like I tell people, like I like it so much because I've looked at it 100 times. Every single time you look at it, you find something new. Like, I recently found this arrow right here that I had never seen before. I was like, there's an arrow, interesting. But that's nothing to do with what I'm about to talk about today, which is European soccer player transfers. Now, in case you read the little intro at the beginning of our meetup, you'll know that I'm going to start off in the 17th century with Isaac Newton. I'm sure you're wondering how I'm going to get to soccer, but we'll get there eventually. So, in the 17th century, Isaac Newton brought forth his universal law of gravitation. And it basically states that every single particle in the universe is attracted to other particles in the universe with a force that is a function of its mass and of the distance between the centers of those two objects. Now, what does that actually mean? Because obviously it's a weird sentence. What it means is, if you take the Earth and the Moon, if you want to calculate the force between them, you can use a function which is equal to F is equal to G n1 times n2 divided by distance, where F, of course, is the force, G is the gravitational constant between the Earth and the Moon, m1 and m2 are the masses of the objects, and then distance is obviously the distance between the Earth and the Moon. Now, conceptually, if you think about the question, why does the Moon revolve around the Earth instead of the Earth revolving around Jupiter? If you use the whole function that Isaac Newton basically created, you would think that, well, the Earth is obviously, it has the mass of one Earth, but Jupiter has the mass of 317 Earths. So given that they're actually bigger, they should actually revolve around each other, given that the Moon is only 0.0123 times the size of the Earth, right? And basically the whole concept is that, of course, the distance between the Moon and the Earth is only 240,000 miles, whereas the distance between the Jupiter and the Earth is actually 449 million miles. So the simple answer is that they're really far apart, so they're not going to revolve around each other. Now, in the 20th century, there was a Dutch economist by the name of Jan Tinbergen. And he actually took this whole concept of Isaac Newton and applied it to trade between countries around the world. So he created what we call the gravity model of international trade, where, let me share my little pointer, here we go, where instead of saying the force between objects, he said that instead you would take the trade between countries, and instead of doing the sizes of the objects, you would take the GDP of the countries, and then distance is obviously the distance between the countries, and then C, instead of being gravity, was just a constant. And in order to give you an example, if you look at the trade between the United States and Germany versus the United States and Mexico, what you see is that in 2019, the United States exported $60 billion worth of goods and services to Germany. However, to Mexico, the United States exported $256 billion worth of goods and services. Now, if you look at the GDPs of the two countries, the GDP of Germany is $3.8 trillion, but the GDP of Mexico is $1.2 trillion. So you would think that there would be more trade between the United States and Germany because they have a higher GDP relative to Mexico. But obviously the simplistic answer is that there's literally the entire Atlantic Ocean in between the United States and Germany, whereas Mexico is right next door to the United States. So it's simple. They're right next door, so it's very easy to trade, instead of Germany being literally, again, across the Atlantic Ocean. Now, from here, I'm going to take the next couple slides, and I'm going to geek out on a bunch of math and logs, which is actually really cool. However, if you want to follow along, I find it cool. It's basically the proof of gravity trade models. And in order to do this, Tinbergen basically built an econometric regression model based on this equation. So what he did was he took the log of trade, right? So he took the log of trade, which whenever you do something to the left side of an equation, you have to do the exact same thing to the right side of the equation. So then he took the log of C times GDPs divided by distance. However, logs actually are kind of cool because they have rules to them. So the first rule of logs is that the log of x times y is equal to the log of x plus the log of y. So the right side of this equation can actually be rewritten to be log of x times y, where x is equal to c, the constant, and y is equal to GDP divided by distance. And then once you do that, you end up with equation 1, where it's log of trade is equal to the log of c plus the log of GDP divided by distance. From here, you take that exact same equation and you use the second rule of logs. Now, the second rule of logs is that the log of x divided by y is equal to the log of x minus log of y. So in here, you actually see that you can actually rewrite this part of the equation to be log of x minus log of y, where x is equal to GDPs and y is equal to distance. So from here, you then end up with equation 2, where log of trade is equal to log of c plus the log of GDPs minus the log of distance. Next, if you take that same equation 2, and then you go back to rule 1, where the log of x times y is equal to log of x plus the log of y, you can see that in here, you actually multiply the GDPs together. So therefore, it can be rewritten to read log of x plus log of y, where x is equal to the GDP of country I, and y is equal to GDP of country J. And then you basically end up with equation 3. And equation 3 is log of c plus the log of GDP plus the log of GDP minus the log of distance. From here, like I said, it's a lot of proofs, but it's actually super cool when you put all of it together. There's also rule 3. So in logs, whenever you take the log of x to an exponent, you can actually rewrite that to be the exponent log of x. So in this case, log x of mu is mu log of x. And what you actually see is that all these GDPs and distance have an alpha, a beta, and a theta. So you can actually bring that in front of the equation to be alpha log of GDP plus beta log of GDP minus theta log of distance. Now, if you actually look at this equation 4, it looks like a regression model, right? Where you have your y variable is equal to some constant plus beta 1 x1 plus beta 2 x2 minus beta 3 x3. So it actually is a regression equation. And this is what we end up with as the gravity model. Now, there's actually 2 more rules that are important when you actually are doing the regression itself. So rule number 4 of logs is that log of negative numbers are actually undefined. So you can't actually, they don't exist. And the 5th rule is that the log of 0 is also undefined. Now, what that actually means is that when you run your regression model, you can't have negative trade between countries. So you ultimately end up having 2 rows for every single country combination. So for example, you'll have 1 row for exports from the United States to Mexico, And the second row will be the exports from Mexico to the United States. Therefore, you don't end up with negative trade balances. And the second rule of log of zero is that there actually has to be trade between countries, because if you take the log of zero, you end up with an error message in your regression model. So what that means is if there's zero trade between country pairs, you actually have to exclude them from your model. And at this point, you might be wondering, what does this actually have to do with soccer? Yeah, a lot of people have like, what is this? So what we actually end up doing is applying this to soccer player transfers. So in the world of soccer, the way it works is you generally get contracted for, when you sign with a club, you sign with them for X number of years. And players usually sign from like 1 to 5 years with them. Now, during those number of years that you're actually contracted to the club, they can actually sell you to another club for X amount of money. And for example, in 2018, Cristiano Ronaldo was sold from Real Madrid to Juventus for 100 million euros. And basically they sold him and now he plays for Juventus, and then that's how the world of soccer works. It's bizarre. However, what we can then do is take this trade equation and actually convert it to the soccer player transfer model, where instead of saying the log of trade, we can do the log of transfer amounts, which is the amount of money that is spent on these players. And instead of doing the GDPs of the countries, we can do the size of the importing club and the size of the exporting club. And then the distance is obviously the distance between the two clubs. Now, when we actually talk about transfer amounts, it is the y variable in this scenario is a numerical value in euros that is paid for the player by the importing club to the exporting club, right? So it's that 100 million euros that was spent. The size of the importing clubs, I ended up having to use the league table position in the prior season to when the transfer actually occurred. So it's a numerical value between 1 and 20. And I'll explain this variable in a little bit in the next slide. And then the distance is the distance in kilometers between the home stadiums of the importing and the exporting club. So when we talk about league table position, in the world of soccer, in case you don't know, in the English Premier League, which is the first division of England, there is 20 teams, and they play each other twice per season. So every single team plays 38 games. If you win the game, you end up with 3 points. If you tie, you get 1 point. And if you lose, you get 0 points. And at the end of the season, the team that ends up with the most points wins the league. So in 2020-21, Manchester City won because they had 86 points. Now, the variable that I end up using is this variable in green, which is the numerical value of 1 to 20, which is obviously first place, second place, third place, and so on. Now, originally, I didn't actually want to use this variable, but I ended up having to use it as a proxy. What I actually wanted to use was the total revenue for the club for every single season, which is sort of like what GDP is to a certain degree, but it's not the exact same, but it's close enough. Unfortunately, however, finding the total revenue for all of these clubs going back for 5 different leagues, going back 20 years, is not that easy. Like actually started going down the route, and I had to find financials that they post, and I was literally looking through like literally hundreds of pages to find one number, and I'm like, I'm not going to do this. Instead, I ended up using a proxy, which is the league table position, because regardless, like, you know, to a certain degree in soccer, the teams that are the richest generally end up winning the league. That's generally how it works. Matthias, do you have a question?
Yeah, just I was curious, have you thought about particularly because leagues have different sizes, using something like a UEFA coefficient. So like, for example, all these all the transfers that you've talked about so far take place in Europe, and the UEFA governing body has like a coefficient that they assign teams based on their performance over the past 5 years, right? And they rank all teams across all the leagues that are in Europe. I was just wondering if you thought that might be something that could be used as well to denote like the GDP of the club, so to say.
That definitely makes sense. I do know the coefficient exists. I do not know how far back, because this goes back to 2000. I could look at that because I have used that for other blog posts that I have. I could use that probably.
Right. The coefficient only takes into account the previous 5 years performance of the club. So but the coefficient changes over time. So maybe what you could do is look at the coefficient over time. You take like a rolling average. Just a thought. Sorry.
Yeah, I think it's I think first I know like I have looked at that even at like the World Cup level. And the problem that I have with using the actual coefficient is it is a continuous ever-growing variable. So with time, it gets the numerical. So I won't go into details, but I thought about doing that for like at the World Cup level, and I decided not to because of a very specific reason that I won't go into because it's a lot of details that you don't need to know. But yes, it's at the club level, potentially I could use that. At the country level, I decided not to use it for a very specific reason that again, I won't go into because it's a lot of details you don't need to know. But definitely, so that's the league table position. The next one is the distance. And when I mean the distance, it is literally the distance between the two stadiums, and it's a straight line. So it's the bird's eye view, the as the crow flies, however you want to call it. That's how I end up taking the distance. Now, in summary, this is essentially everything that I had to get put together for the model. So the model actually has the y variable, which is the transfer amounts between club I and club J at time t, so every single season. Then the size is the importing club position of club I at time t minus 1, and then the club position for the exporting club at time t minus 1, and then I have to take the log of the distance plus 1 between club I and club J. Now, the reason I end up taking the distance plus 1 is because, again, as I mentioned, the log of 0 is undefined. So there are some actual clubs that share stadiums, and there's trade between them. So for example, in Milan, you have Inter Milan and AC Milan who share the San Siro. So the distance is actually 0. And then you also have Roma and Lazio who share the Stadio Olimpico, and therefore the distance is 0. So taking the log of distance plus 1 gives you log of 1, which is still 0. So it computes. Because obviously if you do the log of 0, then you end up with error. Niall, you have a question?
Yeah, I was just wondering about about that, why is it 1? I understand why you can't have log of 0, but sometimes the two clubs that share the same stadium, they don't often get on very well with each other. So shouldn't the distance be a bit longer?
You mean add more than 1?
Yeah, exactly.
You can add whatever constant you want to a distance. It's adding 1 to all of the distances, so it's basically scaling. So yes, you can add whatever scalar you want. It's
okay. No, I get you. Like, I'm a math guy, so I was just like, you can add any constant you want. I get that. Okay, brilliant. Thanks.
Yeah, definitely. Thanks. No problem. In summary, I actually end up having to get 4 different pieces of data. So the first is player transfers, which is obviously the y variable. Then I need to end up getting league tables so I can calculate the position of the club. And then I also need to get the name of the stadium address. And then I actually had to geocode those stadium addresses so I can actually get the distance between those geocodes. So a lot of fun stuff. It's kind of cool. And I actually end up having to get this data going back to the year 2000 for the English Premier League, German Bundesliga, Italian Serie A, French Ligue 1, and Spanish La Liga. And there is a note that I have to say. So I do not take into consideration the transfers from the second division of Spain to the first division of England, right? Because the way I think about it is technically the first place of the second division of Spain is not on the same financial standing as the first place in the first division of England, if that makes sense, right? Because they're lower teams, so they're not as financially stable. Not as financially on the same level. For example, you can in the English Premier League, you might have a Manchester City who is on the same financial standing as Bayern Munich in the German league. So you can say, yeah, they're fairly, Manchester City is on the same level as Bayern Munich, as AC Milan, or Juventus, as PSG, as well as Barcelona or Real Madrid. Like you can say that they're on the same financial standing. However, they're not on the same standing as like a team in the second division of any of these countries. And again,
So,
go ahead, sorry.
Yeah. I mean, just getting on that. There's another reason why they're different, and like Spanish and Italian leagues they use their second and third team and they play them in the lower leagues.
Mm-hmm.
I don't think that's allowed in the English Premier League.
Right. Yeah, and it's definitely that's something that I think changed regardless, but yeah, that definitely makes sense.
Yeah, I think it definitely influences the finances involved in this. Where certain like Barcelona's B team will never go up to can never go up to the Premier League in Spain, for example. So there's less sponsorship and less viewership as well.
Yeah, and again, that's the whole moral idea is they're not on the same financial standing. So basically saying that their position is one isn't really accurate. Now, in order to get all this data, I actually end up going to this site. Let me stop sharing my screen. Okay, sorry. So I actually end up going to this site called transfermarket.com. And on this website, they have a bunch of weird ads. They're always kind of funny. But the point is, they have, for example, here you have Chelsea Football Club, which is my favorite soccer team. And in here, they have information about their stadium. And they have the capacity, the year was built, and a bunch of other stuff. And over here, they actually have the address for the stadium. So this is the data that I need. And in order to do this, I actually have to use literally my favorite R package, which is called rvest. I don't know what it's called that, but it's cool. And rvest is an R package they use to web scrape. So the main functionality of rvest is three different functions that I use. So I use read HTML, where you simply input the URL of the website that you're trying to scrape. Next, I input HTML nodes, which is the node of the text that you're trying to scrape. And then you simply pass it to HTML text to convert it into a text variable, into a text string. Oops, let me move this thing to the side. This thing is, oh, there we go. And does someone have a question or no? Okay, cool. Now, in case anybody has ever tried a web scrape, there's a couple of ways you can do it. The hardest part is honestly trying to find the HTML node. So in case you ever tried, one way you can actually do it is if you like go to some text and you right click and you go to inspect, you'll have this thing pop up on the side, and it's like a bunch of it's a bunch of code in the background that's used to build the website. And in here, you can clearly see that it says Fulham Road, and then you can try to find like the class up here of the node that you're actually supposed to use to web scrape this Fulham Road. I don't use this because honestly, I never can make it work. Or you can also like right click, and then you can go to like view page source. and it basically shows you this, which is also a bunch of code in the background. And if you actually search for Fulham Road, you'll find it right here. And then you can, again, try to find the HTML node if you can do it this way. I can't, because I've never really tried that hard either. Instead, what I use is a Chrome extension called Selector Gadget. And it's a Chrome extension, it's free, you can get it. And what it simply does is once you turn it on, you can actually click on, you'll see that if you start moving around your mouse, you'll see that you can click on stuff and it'll highlight stuff in different colors. And what it actually is when you click on something, it basically turns a bunch of other stuff in yellow. And what you want to do is make sure that you only have one thing, which is the text that you're trying to scrape, in green. So you want to get rid of all the stuff in yellow. Doesn't make any sense, it just works. That's how this thing works. But you click on a bunch of stuff until you get everything that's in yellow. Right, sorry, let me try again. Everything in yellow to go away. And you know that it's going to go away when you see this little thing down here have a 1. And this basically then ends up being the HTML node for specifically Fulham Road. And then you can do the exact same thing for the next one and the street, the name, and the city, and all that stuff. It's actually a really cool thing. It's like, I could not do web scraping without it. It's literally, I would actually pay money for this thing. And it's free. Now, when you actually go to R, the way this whole thing functions, again, is you load rvest, then you use the function read HTML, and you put in the URL of the website that you're trying to scrape. And then you pass the URL to HTML node. And in here, you put the HTML node of the text that you're trying to scrape, and then you pass it to HTML text. And this is a node for the first one, then the second one, third, and so on. And when you actually run this whole thing, what you'll see is that you end up with Stamford Bridge, Fulham Road, SW6 1HS, London, England. This is exactly what is on the site. Like, it's basically these 4 lines of code of text. And you essentially can scrape it using rvest and R. Now, I'm going to skip over a bunch of steps that you would essentially do to scrape the entire list. But what you would essentially end up doing is you get a list of all these URLs that you want to scrape. And then you actually have to create a function which reads in the URL, takes the HTML node, and creates a data set, and then puts all the data set together. And then you can take that list and you run it through an lapply on the function that you created, and you can basically web scrape an entire list of URLs that you have. And that's generally the purpose, the process that people go through when they're actually web scraping. Again, I won't go into details because everybody built it differently, but conceptually, that's what it is. And when you, let me share my screen. No, sorry, my PowerPoint. Selector Gadget, here's code, yes. So after you're actually done with the list and you run it through your function and you end up scraping all the websites, this is what you end up with, which is a data set where you have the name of the stadium, the club, and then the address. And in here, you'll see Chelsea and you'll see Fulham Road, the address of this actual stadium. And that's how you web scrape stadium addresses from a website. Now from here, next step I had to do is I actually have to geocode all of these addresses in order to actually calculate the distance between all the addresses. And I'm sure that people have their own way of geocoding stuff. I prefer to use the Google Maps geocoding API with R. Now, it's a service provided by Google Maps where you can actually connect to their API with R, and you can literally run the entire process in RStudio. Now, I will give a by the way disclaimer type of thing. they charge you to use their API. So they charge you 0.005 cents per each hit to the API. However, they give you $200 a month for free. So that basically equates to 40,000 hits to their API per month for free. If you're doing more than 40,000 a month, I don't know what you're doing, but it's you might end up having to pay, right? And it's right. I didn't actually have to pay for all this stuff. It was like free for me to use. However, when you use to use their API, you have to use the ggmap package. And what you end up using is, let me get my little laser pointer, is register Google, where you simply have to input your API key. And that's basically a key that Google gives you so that they can actually use it to charge you for all the uses. It's, again, it's how they authenticate you. And then you simply run the mutate geocode function from ggmap, and you insert what your data frame is, and then you insert what the name of the column that has the addresses that you're actually trying to web scrape. And that's pretty much it. And you run the whole thing, and usually it doesn't take a long time. It's just like, I did it once, so I have no idea how long it took. But you end up with a data set that looks like this, where you have the address, and then it gives you the longitude and the latitude of the specific address. And the next question you might be wondering is, how good is it though? Because obviously, if you're paying for it, it better be good. And when I originally did this, I had 2,651 total stadiums I had geocode. ggmap was able to process 99.09% of them, so virtually all of them that I needed. And that's how good it is. It's, again, it was for my case use. I'm sure it's, but then again, if I'm literally geocoding stadiums in like Uganda, if it's this good, you'd probably be good for whatever it is that you might have it used for it. And then the next process that I actually had to do was to calculate the distance between all these geocodes. So in this example, I have Arsenal from London, England, and this is the latitude and longitude of their stadium. And then we have a list of all the different clubs that they either sold or bought players for, and the longitude and latitude. So I simply have to calculate what the distance is between these different geocodes. And in order to do so, I use the geosphere package. So geosphere has a distance m function, where you simply have to input what your longitude and latitude are for your x variable, which in this case, it's the Arsenal ones. And then the y, which is the longitude and latitude of the clubs that they're actually trading with. And then you have to specify the distance Harris-Fein function. And this function basically is like, again, it's a straight shot in between the 2 points. It's as the crow flies, as birds fly, however you want to call it. But once we actually run this whole function, you end up with this that looks like this, where it shows the geocodes of the 2 different ones that you calculate the distance for, and it gives you the distance in meters. And then you can obviously divide by 1,000 to get kilometers. And it's that easy. So it's actually not that hard. Now, from here, the next step that I actually had to take was to web scrape the league table from, again, transfer market. So let me stop sharing my screen and go to that site real quick. Definitely. So transfer market also has the league table that I need to scrape. And again, the column that I want is this column, is the first column here. But I web scrape the whole thing anyways, because it's not that easy. It's that easy. Now, here's where scraping kind of takes a different turn, where if you think about it, you could potentially find the HTML node for this specific cell by clicking a bunch of stuff in yellow. There's one out here, right? And you can find the HTML node for specifically this one cell right here in this is what it is. And then you can do it for the second row, the second cell, the third, and so on. And then for this one, this one, and this one, and for all of these, right? So what you end up, you could potentially find the node for a table that is 20 rows by 9 columns. You don't want to do that though. That's like 180 different HTML nodes you have to find and create a function that scrapes every single one of them. You don't want to do that. That's a lot. So alternatively, what you can actually do is web scrape the entire column. So if you click on here, you'll see that, again, it highlights a bunch of stuff in yellow. If you click on the actual number, and then there's a couple down here, this is the HTML node for the entire column of club. And then you can also do this for the matches by clicking a bunch of stuff, and then down here, yeah. And this is the HTML node for the matches, and then the wins, draws, and so on. So you can do this at the column level. So in that case, you only need to find 9 different HTML nodes. And that's essentially what I end up doing. So in this second example, you again use read HTML to read the function, to read in the website, and then you create a data frame of all of these different HTML nodes that you were able to find. And once you run that, oh, where's X? Sorry. Why did it create a list? Did it not run? Sorry. Why did we skip a list? Sorry, real quick. This is why I don't like doing live. Sorry, 1 second. This is taking way too long for it to. That's weird. This literally worked right before. Here we go, sorry. What you end up with is a table that looks like this, where you have the clubs, the position, the matches, the wins, draw, losses, and so on. And it's basically this exact same table that you see right here. And again, I only had to find 9 HTML nodes instead of 180. Now from here, let me go back to my PowerPoint. You end up, here's the code. And then the next part that you actually have to web scrape is the actual transfers themselves. So again, the Y variable. And then let me go to that site real quick. Now, transfer market, as you might imagine, their main thing is capturing soccer transfers all over the world. And what you'll see is that in the 2021-2022 season, here's all the players that Arsenal transferred in. So for example, Ben White is 23 years old and he plays as a center back, and he came from Brighton and he cost 58.5 million euros. And then we also have all the players that Arsenal sold. So Joe Willock was sold to Newcastle for 29.4 million euros. Yeah, to euro. And again, in order to actually obtain all this data, you could web scrape. Again, you go through the whole process of web scraping every single cell that you see in here. So this is the HTML node for this one cell, and then you can do it for the second cell, third, and so on. Again, don't do that. That's a lot of web scraping, a lot of nodes you have to find. Alternatively, as I did with the league tables, you can actually web scrape the entire column. So if you do that, you end up with this column, which is 507 rows for 507 players that were transferred. And you can actually web scrape the entire column at once. However, the problem doing this is that in here you have the first table is 10 rows. The second table is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 13. So you'll end up with the column where you have 10 rows as Arsenal coming in, and then 13, I think that's what he said, of Arsenal coming out. And then you do it for Aston Villa, and the number of rows, sorry, also changes. So intuitively, you're like, there's no way you can actually figure out like which where the cut is. Like you really can't figure out. I tried. So instead, what I end up doing is this third process, which is using HTML table, which is a bit different, where instead of web scraping a specific text in the string, a text as a string, it web scrapes every single table on this entire site, which once you actually run this whole thing, sorry, you end up with, whenever it finishes, it's actually quite slow right now. I don't know why. Oh, whatever. The point is, what you end up with is a list of 43 tables. And honestly, I don't know why it's taking so long. Sorry. Again, that's why I don't like doing live.
When you say it creates 43 different tables, are you talking 43 different transfers in and transfers out tables?
Yes, plus 3 extra that get web scraped as well. So this really thing is, sorry, do I not have? Sorry, I thought I had.
So just wanted to confirm. So for example, you will have 2 tables here. The first one being Arsenal's transfers in table, and another that is Arsenal's transfers out table.
Yes, yeah. And sorry, it really take a long time. I have no idea why, but the point is, I can talk to it. It's what you end up with is, again, 43 tables. And the first 3 are actually a bunch of gibberish. They're nothing that you need. When you get to the 4th table, that's where you have Arsenal coming in. The 5th table is Arsenal going out. So what you then figure out is that 4, 6, 8, 10, 12, and so on are the transfers coming in. 5, 7, 9, 11, 13, and so on are the ones that are going out. So therefore, should I close this thing? I have no idea. It's fine, whatever. I'll just talk through the whole thing. So what you figure out is that all the evens are transfers coming in, all the odds are transfers going out. So what you end up doing is separating the tables by, are they even or odds? And then you basically stack them on top of each other. And this thing is not going to run, so I'm just going to continue. And then let me continue with my little presentation. And what you actually end up doing is, again, taking all of the evens and stacking them on top of the odds. And then you basically stack 4 on top of 5, and then 6 on top of 7, 8 on top of 9, and so on. And what you end up with is all the different transfer for Arsenal coming in, and then all those coming out. And you can, in this scenario, it's the 2021 season, Arsenal, and here's all the players that left and where they went to or where they come from, and how much they were transferred for. Sorry, again, I don't like doing live sessions with RStudio because it always airs out on you, but regardless, I'm sure you guys can like conceptualize what I just explained. Or let me see if it worked now. Still running. Okay, I'm just gonna kill it. There we go. Let me try one more time. No, whatever. It's usually not, doesn't take this long. Regardless, the point is, after you then, whatever, the point is, sorry. Right, now from there, after you get all the transfers and all the positions and all the distance between the geocodes, you can actually put all of this stuff together. So in this case, we have Chelsea, because again, they're my favorite soccer team. And so the way you read all this data is in the 2019-2020 season, they bought one player from Real Madrid, and that player cost 45 million euros. And in the 2018-2019 season, both Real Madrid and Chelsea ended up in a 3rd position of their league. So that's club position at time t -1. And the distance between Stamford Bridge and Santiago Bernabeu in Madrid. That's the name of the stadiums. They have really weird stadium names in soccer. It's super fun. But the distance between those stadiums is actually 1,253 kilometers. And then this is essentially the data that gets ran through the model. And then let me show you a couple graphs just to show you some cool graphs because I find them super interesting. This graph, the y-axis is the count of transfer counts. So it's essentially how many transfers that occurred. And what you can see is that the blue line, since the 2008-2009 season has historically been the highest line out of all of them, which is Italy, meaning that the Italian Serie A in general over the last number of seasons, they've been the league that has imported the most number of players. And the next one is the English Premier Leagues, because they also import a lot of players. And the next graph is essentially the sum of these transfer amounts. So what you see here is that by season, the total number of money that is being spent by these leagues. And what you obviously see is that the red line has historically been the highest, and that's the English Premier League. Now, if you look at this graph and you know a lot about soccer, it literally becomes super interesting when you find little pieces here and there. So for example, in here, you'll see a big peak for Italy. This was when Gianluigi Buffon was bought by Juventus for a crap ton of money, which is that's even a big peak right here. This peak that you see right here for the Spanish La Liga was when Cristiano Ronaldo and Kaká were bought for a lot of money as well. That was a record at the time. And then what you also see is up here is the transfer of Romelu Lukaku to Manchester United. Yeah, Manchester United. So it's literally, this peak alone is Lukaku. And one of the other interesting tidbits that at least I like to see when you look at this graph is if you actually pinpoint the 2013-2014 season, what you start seeing is that like all of these lines start going up, right? They start kind of like increasing. Whereas historically, I mean, on average, they were kind of flat. So something in this specific season caused all these leagues to start spending a lot more money. However, the other thing is that obviously the difference between the English Premier League and the other leagues started outpacing each other. Like they're spending a lot more money than the other leagues combined, even though everybody's spending more money. Super interesting. That's a whole different conversation for later. But again, when I first did this graph, I was staring at it for like 20 minutes, just like trying to find like every single little tidbit. I'm like, why is this peak here? Why is this happening? It's super fun. However, from here, the next graph that I'm going to show you is a scatter plot. Again, not super complicated, but the y-axis is the log of the transfer amounts, and then the x-axis is the import club position, so that x variable of size. And what you can generally see is that it's a downward sloping curve. So as club position gets closer to 1, the amount of money that is being spent on the players coming into that club is higher, which makes sense. Like obviously, if you're a team with a lot of money, you're buying really expensive players because you can afford them. And the same thing happens for the exporting club. So it's a downward sloping curve where the closer you get to the first place, the higher the transfer amounts is. So it's makes sense. Then you get to distance. So for distance, again, I take the log of distance plus 1. And what you see is that this line, all of these lines are pretty much upward sloping, which is interesting. Because when you actually run the regression model through an OLS regression, because that's usually how gravity models are ran, you end up with the y variable, again, being the log of transfer amounts. You end up with import club position with a negative 0.10 coefficient. Now, in general, gravity models are ran log. And you would then interpret the beta coefficient as a 1% increase in X is correspondent to a whatever the coefficient is percent increase in whatever the Y variable is. However, when you're doing gravity models, it makes sense to understand the concept of like 1% increase in GDP. That makes sense, right? When you think about 1% increase in club position, doesn't really make sense. It's kind of like, what does that even mean? Because it's a discrete variable between 1 and 20. So as a result, I left it as simply 1 and 20. So I did not log it. But the way you interpret the beta coefficient regardless is if you increase import club position by 1, so for example, going from a 10 to 11, on average, the amount of money that is being spent on the player by the imported club is 10% cheaper, right? Or vice versa. If you go from an 11 to a 10, you can expect that the players that you're going to be buying are 10% more expensive. And then for the exporting club position, you can also think concept of if you increase it from a 10 to 11, you can expect to sell the players for 3% less. And then you get to distance, which basically means since it's a log, you can say that a 1% increase in the distance between these clubs is going to result in a 7.8% increase in the price of these players. And the most interesting part of this whole thing is that it's a positive coefficient, which is the complete inverse of what gravity models are, right? Because they'd say as distance gets bigger, the force or the trade gets smaller. But here it's actually positive. So as distance gets bigger, the amount of money that's being spent actually gets bigger. Matthias, did you have a question?
Yeah, looking at the original gravity equation, the intercept, would that be log C, right? That
Yeah.
log C variable. That in the original model, what was C? C was a gravitational constant, right?
Yes, that's how you usually think about in obviously gravity is a constant, which is 9.8 meters per second squared, if I remember correctly.
Yeah. So then, but that constant would be different between each individual club, right? So the intercept for example, from Chelsea to Arsenal would be different from the intercept from Chelsea to Real Madrid.
Different intercepts. Yeah, I guess you can say that. Yeah, in general, it's like honestly in the world.
It would be a log constant, right?
Yeah.
It would be,
yeah, and that's and the intercept is basically on average. The general bubble is essentially 15.9. Like yes, it's different across all of them, but on average is 15.9. Yeah, in economics, we really don't pay much attention to intercept. It's kind of like just like we just leave it there. It's like you throw it in there. It's really never important. Even if it was not statistically significant, to economists, it kind of doesn't mean much. But overall, again, the idea is the positive coefficient. And here is my theory on why it's positive. So again, it's just a theory. If we look at the top 20 transfers in all of soccer history, what we obviously know is that the most expensive player ever, which I don't like because I just don't like him, was Neymar at 222 million euros, which is a complete waste of money, in my opinion, but to each their own. And obviously he was sold from Barcelona to PSG back in 2017. The next one was Kylian Mbappe, then Philippe Coutinho, then Dembele, and so on. Now, if you look at the 6 players that are highlighted in green, so Mbappe, Griezmann, Higuain, Maguire, Lukaku, and Van Dijk, what you see is that they're actually transferred from within the same league. So Mbappe went from Monaco to PSG, Antoine Griezmann went from Atletico Madrid to Barcelona, Higuain from Napoli to Juventus, and so on. And then if you actually put up the distance variable next to them, and you color code it from red, yellow, green, where green means it's a higher distance, in general, what you see is that all of these that are highlighted in green actually have a red or a yellow or an orange color to them, which means that the distance is actually small, which makes complete sense, right? How much, if you look at the distance between Monaco and Paris, they're in the same country. So you can expect them to be relatively small compared to Liverpool versus Barcelona. Like that's actually really far away, right? Which basically means if you're selling, sorry, lost my train of thought, right? So from here, I like to think about it like this. When Barcelona was going to sell Neymar, okay, they know they can sell him for a lot of money because he's actually a really good player, even though I don't like him. But that's, again, separate issue. If in the Spanish La Liga, there was honestly two teams that could actually afford Neymar, other than Barcelona, Atletico Madrid and Real Madrid. Now, independent of the fact that Barcelona and Madrid hate each other because of Franco and a bunch of other stuff in history, if they were going to sell Neymar, who's a really good player, would you really sell him to Real Madrid or Atletico Madrid, knowing that they're actually in the same league, so they're going to be essentially use them against you, right? You're selling your best player, well, not the best player, but a really good player to one of your competitors, right? You wouldn't ever do that. Like you would not sell your best players to your competitors, right? So what that actually means is that if you're going to sell your best player, who in turn actually is sold, you can sell him for a lot of money because he's really good. You're not going to sell him to your competitors. You're going to sell him to somebody who is far away from you. What that then causes is the distance variable to be bigger because you want them as far away from you as possible. That way they can't actually use them against you. And yes, I know you can technically say that Barcelona and PSG compete in the Champions League, but again, that's a whole different thing on the side because that is a thing, but that's on the side. And that's essentially my theory. My whole theory is you're not going to sell your best players, who in turn can be sold for a high price to your competitors. You're going to sell them really far away. In turn, causes the distance variable to be higher the more you actually sell the player. The higher you sell the player, sorry. Anyways, I practiced this. It was like the bigger the distance. Sorry, I totally lost my train of thought. I have no idea what I'm saying at this point. I'm sure you guys get the point that like you're selling him far away because you don't want him to actually compete against you. So from here, if we go back to the regression model and you insert a new variable, which is actually same league, which means is the player being sold within the same league or not? So it's a binary variable 1 or 0. What you can see is that it's statistically significant at the 1% level. So if you sell a player within the players that are being sold within the same league, on average, are 42.7% cheaper than those players that are being sold outside of your league. That is my whole time, and that is my entire little thing that I've been playing around with for the last year. Because yeah, it's COVID kind of gave me a lot of time to do stuff like this, so I really enjoy it. Thank you very much, and that's literally an hour. Wow. Thank you.
Great. Thanks so much, Andres. I'm sure there's going to be some questions. So people go ahead and unmute yourselves or throw it in the chat. Feel free to ask questions.
Thanks, and thanks. That was very informative. Where can we find the recording of this video?
On the YouTube channel, I think John usually posts.
Yeah, I can throw in the chat. We have a YouTube channel, so it'll be posted. Use it within a week. Depends on how busy Tim is, but I'll throw it in the chat so you can find it.
Great, thank you. So you guys are in Flatiron, is that correct?
Excuse me?
sorry, I signed up for this like a month ago, and I forgot where you guys are located.
That's,
Um,
yeah, we're in
It just
Cleveland,
popped up.
Cleveland, Ohio.
Yeah.
Okay, my bad. Okay, well done, guys. It was very informative.
No worries.
Yeah, thanks. Yeah, and again, like most of the stuff is just like I can literally when COVID hit in March, I was like, I have a bunch of time to do nothing, and I'm like, let me play around with stuff, and I ended up learning how to web scrape, and I'm like, let's see what else I can find. And I mean, this whole concept of like gravity models stuck with me when I was in graduate school, and I'm like, I want to do something with it, but I don't know what. And then when I found transfer market, I'm like, here's transfers, and they move across countries for money. You can apply it. So, and then
So sorry, what other fields apart from soccer have you applied this gravity model?
Well, it's in, so my master's is in economics, and in econometrics, it's usually used for like trade. So it's usually used to say like, okay, for example, Nafta, right? The North American Free Trade Agreement, sorry. Has it actually been, what is the impact of Nafta on trade? Well, you can look at it of trade between the United States, Mexico, and Canada compared to trade with other parts of the world. So what's the effect of Nafta? Or the Eurozone, I guess you can call it, or the whatever, whatever trade agreements there are all around the world, you can usually use gravity models to see their effect on trade. Also, like, what's the effect of like currency changes? Like, if you use the, like in the Eurozone, they all use euros, so there's really no fluctuation in currencies. However, if you trade between the United States and Europe, well, there's differences in currency. So what's the effect of having different currencies? And a bunch of other stuff. They're all pretty interesting, but yeah, I usually do my stuff in soccer because, as you can imagine, it's like trade between countries is not that interesting to me. I prefer soccer. So
cool. Sorry, last question. Like I'm a ex-math teacher and a soccer coach. So I know a good amount of stats, but I know little about R. How difficult do you think it is to pick it up to be able to do something like you just demonstrated? If you were just going to, given my background, like math teacher, stats guy, soccer into,
I personally believe that when you start getting to the web scraping part, like I literally glossed over it, but it's not, every single site has its own, quirks, and they're all different. And like every single time you actually try to web scrape, you run into something new issue. And it really helps if you really know R, because then you can kind of figure out what's the best way to fix this little problem.
But I have past experience in C++, so like I'm sure, but that's 20 years ago. So I'm sure that experience would kind of help me again.
Yeah, definitely. Yeah, I mean, I don't want to say that it's not easy, but I mean, honestly, the how to web scrape the actual Y variable, the transfers, I actually had to like go to the fifth page of Google to find somebody's GitHub page who like Stora did it. They were able to like almost get it to the level that I needed. I'm like, okay, let me see what they did. Let me try to find it and copy the code and like try to tweak it. Like, it's intense. Like,
you gotta be persistent, right? That's what you're saying, but it's not impossible.
No, I mean, I was literally doing this in the summer of, I don't know, when did I start this? Certainly the summer of 20, when I was like literally in my house doing nothing. I'm like, what am I gonna do? So, but yeah, it's but again, it's like, honestly, I think the biggest advice is do it on something you like. Like if I was doing this for like work, I'd be like, this sucks. But if I'm doing it for soccer, something I actually like, I'm actually more likely to stick with it and at least enjoy it. So yeah, it's, again, I create an entire blog for soccer stuff. I'm like, it's the passion is there. I just have to do more stuff with it. So
brilliant. Thanks so much, Andreas. Really good.
There's some questions in the chat if you want to try and address.
Yeah.
I posted a blog. I linked a blog post there. It was about it's using R to analyze soccer data for people with no R experience. So that's the perfect place to start if you're new to R and want to analyze soccer data. So
Definitely. Sorry, I was trying to look at the questions. The Browns need you. The Browns need a miracle. Actually, it's not that bad. Honestly, I live in Cleveland, so I remember 0-17. You can. This is a miracle. Yeah. We're doing really good, honestly. I actually got tickets that season. They were literally $5. I was like, and I didn't go. I was like, I'm like, I don't want to go. I got it for $5. I was like, it's whatever. The point is, question was, how will model change if instead of using rank from 1 to 20, a ratio of 20 versus ranks from 101 to 120, a much smaller ratio? If it's a proxy, not that much really. I mean, honestly, even if I end up having, I don't actually know what the question means, but sorry. They're all proxies to each other, right? It's like using the rank that people gives a club, it's not gonna create much difference. Like, it's like, I could honestly, it doesn't create much difference, honestly. Even in the world of like GDPs, in the world of gravity models for trade, you can actually, instead of using the GDP, you can use the size of the country. It makes no difference, honestly. You can literally use the size of the country, the population of the country, it makes no difference. Like the beta coefficient changes a bit. It's overall the exact same message overall. Because again, the biggest countries in the world are also the most, the ones with the highest GDP, the United States, China, Russia. They also have really big populations. And they're also geographically very big. So it doesn't really matter which one you use. They're all the same. Yeah. Yeah, I don't think there was any other questions specifically in the chat.
well, there's a question is if you looked at Brexit, the effect of Brexit.
Oh, sorry.
Down.
Brexit. Have you looked at the effect of Brexit versus staying in the EU? That would only affect. That's the other thing. It's like when I did this presentation at work for like our club, they're like, "What about this?" I'm like, "How much variance is there? You're literally talking about one country versus 4. Not that much difference." Have you looked at the effect of Brexit versus staying at the EU? No, not really, honestly. This is my first pass at it. It's like the most simplistic model, which is size and distance. Yeah, I don't think there was any other questions. Something about Canada. I'm like,
I think he's pushing back on your population GDP thing, but
yeah, in general, again, that's what regression models are. They're just like on average, in general, like,
yeah,
obviously, yeah, there's always the exceptions, but in general, that's how it always works. Also, what about North Korea? Okay, definitely.
Yeah, I've done the same thing. Okay, I had one quick question to finish off. So the total transfer amount, it looks like you scraped it. That column was pretty nasty. It had like a end of loan and free transfer. And how did you go from free text, essentially? There were some numbers in there, but there was other lots of free text. You just know what those mean? Because to me, not knowing anything about the subject, I saw a lot of strings and not many numbers. So how hard was it to go through there and make those all numbers?
So let me share my screen real quick, because I think it is again, it's like I graze over a bunch of stuff. It is like a lot more complicated than that. So in here, what you see is a very pretty girl. Sorry. You'll see like 38.4 M, 32.3 loan, end of loan. Essentially, it means once you get out all the free transfers, because obviously, as I mentioned, like in soccer, generally you can actually like sell players, but sometimes if your contract expires, you become a free agent and you can go wherever you want, right? So just like in basketball and other sports. So after you get rid of those, and then you get rid of loans, where loans are simply, again, they loan you to another club for some time, and then you end up with anything that, like, you get rid of anything that says end of loan or end of this, whatever, a bunch of stuff. You end up with this. And in here, I mean, you basically get rid of you basically start string mining, where, like, get rid of the euro sign, and then if it's an M, you multiply by whatever. What I did? It took 38.4 multiplied by 1,000? No, 10,000. Let me see. What did I do? I don't remember exactly. 38.4 times. No, so it's 38.4 times a million. Yeah. So you take 38.4 multiplied by a million, and that's how you end up with 38 million euros. And there's also a couple others where you see, like, so let me find one real quick. It'll be like thousands. So it's like some of them are literally hundreds of thousands, where some are like literally millions of dollars. There's none in here, but you'll have sometimes that say, instead of M, they'll say TH, just basically multiply by 1,000 in that case. So you end up with, like, whatever the equivalent in thousands is. So yeah, it's actually not super complicated once you get rid of free transfers, end of loans, all this other, stuff you don't need.
Yeah. My issue is lack of knowledge. I didn't know if those could be converted to a numeric amount or not. So you filtered them out. So that makes sense. That makes it a lot easier.
Yeah, it's you'll see here, like, pound 25 TH $25,000 is your market value. Yeah, something like that. It's again, it's all literally using R. So yeah, it's a very versatile tool.
Okay, great. Any final questions?
Yeah. Well, again, yeah, thanks for having me. And again, it's always nice to actually talk to people about this stuff, because my wife could care less about stuff like this. She's like, she doesn't like soccer, she doesn't like math or anything. I'm like, who am I gonna talk to? My son, he's 6 months old. I'm like, I mean, I practice with him, but I'm like, he's just there, like, staring at me. So thanks.
Yeah. What I'm hearing is I can count on you for another talk in 2022. So I'll be, I look forward to that.
It's gonna be about soccer, like, that is for sure, but I have other stuff, so definitely.
Do you want to answer Craig's question real quick, or is that too involved?
How about using an options model for transfers? Price should decay with time. Do you want to? I don't actually know what an options model is. So if you want to explain that, Craig, if you want to. Is he? Oh, I think he's not. Yeah, yes. Yeah, honestly, I don't know what an options model is, so don't really know.
All right. Okay, we'll end it there then. Thanks, Andres. Thanks everyone for joining. Hope to see you next year. Everyone have a good holiday and end of the year. Bye, everybody.
Thanks. Bye.